Good morning and welcome to Unit 1, Lesson 3. This is talking about rational and irrational numbers. So let's discover what's going on with the differences here. So we're going to take a look at a couple different fractions and we're going to convert them to decimals and see what kind of decimals we get. So if I take 28 and divide by 11 in my calculator, I'm going to get the decimal number 2.545454, etc. So what are we noticing? That this is a repeating digit, which means it goes on forever. So the pattern continues. Forever. So that means it does not terminate, it never ends. So repeating numbers never end, and they are considered rational numbers. Now let's take a look at the number 28 divide 8. Well, this time we're going to get a decimal of 3.5. So this one is one that we considered non-repeating. This guy would be called a terminating decimal. So this guy terminates, meaning he stops or ends. So this decimal doesn't continue. So it's a non-repeating, and it terminates, which means it stops or ends. All right, let's take a look at the root 2 now. So if I convert root 2 to a decimal, I'm going to get 1.414213, etc. And it runs on forever. So this one, again, doesn't have a pattern. So it doesn't repeat. Okay, so there's no pattern. But it's not going to end either, which means it's a run-on. Okay, so there's two different kinds of run-on decimals. A run-on decimal with a pattern, which is repeating, or a run-on decimal with no pattern. So that means that it is always going to be an irrational number. So let's take a look at some of the vocabulary we're going to be dealing with. So repeating decimals, those are the ones that reoccur in a pattern. Okay, so those are the ones that repeat the same pattern. Non-repeating decimals, they have no pattern of digits. So this would be another example of this. If I go 2.141516, it's not repeating the identical pattern. It has to repeat the identical digits to be considered a repeating digit. So this one is a non-repeat because the pattern does not continue identically. So the pattern is not identical. Then we have terminating decimals. This one says it's got a finite number of digits, which means the digits stop. So if there's a terminating decimal, for example, 3.6, 9.8, 2.45, they will end at the end of their number. They will not continue with a pattern. So those are the ones that end or stop. Non-terminating, these are the run-on decimals. Okay, so the non-terminating, and remember there's two different kinds of non-terminating. We have the run-on non-terminating, but we also have repeating decimals that also don't terminate because they run on forever. All right, let's take a look at these examples on the bottom, and we're going to decide what kind of decimal they would be. So if I convert this guy to a decimal, I'm going to get 0.125. And that is a terminating decimal. So this guy terminates. So he's terminating and he's non-repeating. Now we're going to find numbers that end, with a number on the bottom as an 11 or a 9, they typically repeat. So if I look at number 2 divided by 11, I'm going to get a decimal answer of 0.1818, etc. So the 1/8 is repeating. So this is a repeating pattern, but it also doesn't terminate. So it's non-terminating. We're going to look at 9 divided 7, and that's going to give me the number 1.2 0.85714, and then it goes 2, 8, and then I have a 6 at the end. What they've done is because my calculator has run out of room on the screen, they've rounded the last number. Your calculator will always round the last number. So this pattern right here of these numbers is going to repeat right here. Although, because it's 5, 7, the 5, 7 got rounded up to the 6. So that's what happened there. So this is an actually repeating. Whoops, spelling that wrong. This is a repeating decimal. And if it's repeating, it's going to non-terminate, which means it won't end. It'll continue its pattern forever. The next one, it's possible for only one digit to repeat as well. So this guy would be 0.94444, and it would continue forever. So this is a repeating. And again, repeating digits will not terminate, non-terminating. However, square root 8, we're going to get the number 2.82842 and so on. And there is no pattern. So if there's no pattern, this guy does not repeat. So he's non-repeating. And he's going to go on forever. So he's non-terminating. So the non-terminating means they're going to run on forever and continue. Now, if I go square root 0.16, I'm going to get 0.4. That is a terminating decimal. And so it stops and it's not repeating. So it's a non-repeating. All right, let's turn the page and see what other kinds of numbers we're going to deal with. Now we're going to discover the difference between rational and irrational numbers. This is section B. So it's telling us that rational numbers are numbers that repeat or terminate. So those are the two different types of decimals you can get. And they can be converted into fractions. So these ones can be in the form a over b, where b does not equal 0. And that just means the bottom of any fraction cannot be a 0. So these ones, they can be written as a ratio of two integers, meaning a number on top of another number. Does it always solve to be a whole number? No, it doesn't. It can solve to be a fraction or a decimal or an integer. Now, irrational numbers, these are the non-repeating, non-terminating. And the biggest things a huge difference between the two is they cannot be put into fraction form. Okay, so irrational numbers cannot be put into a fraction. That is the biggest difference. They are run-on decimals with no pattern that go on forever. A good example of run-on decimals that we all know, and it's a button on our calculators, is called pi. Let's see if it's going to give me, it's not letting me write. Okay, continuing on, we're going to take a look at all these 6 examples below and see what kinds of decimals they are, and if we can convert them into fractions. So in our calculator, to convert numbers into fractions, what we do is we hit our math button and then enter. Now, of course, we have to put the fraction number in first, or the decimal number. So if I put my decimal number in first, I would go 1.493, and then I would hit math, enter. And it's going to give me a fraction of 1.493 over 1,000. Okay, so yes, this one can be put into a fraction. So that means he is rational. And he is a terminating decimal. Now let's take a look at the number square root 5. Square root 5 as a decimal is going to give me 2.8 2, 3, 6, 0, 6, and so on. So this is a run-on, non-terminating, and non-repeating. Okay? And then we look at the third one. We have 2.347, 347, 347. So 347 is repeating. So this is a repeat, which means it's non-terminating. Let's look at the next three. So whenever you've got a square root, you need to solve it, just like we solved this one right here on B. So on D, we're going to solve, and we're going to get -9. It's an integer. So we know that it's a terminating decimal because I can go 0.0. So it's a terminating decimal. And it's non-repeating. Let's look at the next one. This is going to give me 2.1, which can be put into a fraction as 21/10. So this is non-repeat, and it's terminating. Oops, terminating. ing. And then let's look at the second one, the last one. Now, when you look at the last one, it does appear to have a pattern, but is it repeating the identical pattern every time? So here it's got 1, 1, 2, 2. If it's repeating the same pattern, these numbers should have been a 1, 1, 2, 2, and it's not. They add 3 1s and 3 2s, then 4 1s, and then it'll be 4 2s. So this is non-terminating, and it's a non-repeat. Okay, this is not the same pattern. It's got to be identical. So when we classify these now we're going to classify them as rational or irrational. Now, because rational numbers can be put into a fraction, A over B, we call them Q for quotients. They can be put into a quotient. So that's its symbol. And then irrational numbers, we call them not rational. So we start with our rational symbol, and then we put a negative sign on top of them that says not rational. Okay, so now what we're going to do is we're going to go through each one of these and classify them according to what kind of decimals we've written down. So this one we've already discussed is rational because we can put them into a fraction. This one is a run-on. If he's a run-on, he is irrational with no pattern. However, C is a repeating decimal, so he's rational. D is a terminating decimal, rational. E can be put into a fraction, rational. However, F, not the same identical pattern, so he's irrational. So the two that we should have discussed as or found as irrational are B and F. All right, continuing down. Now we want to order irrational numbers on a number line. In order to do so, what we do is we convert to decimals first. And that's going to tell us their approximation place. So root 14, I'm going to get 3.741, etc. It's going to run on forever, of course. Pi 3.14, etc. Root 80, 8.944, and running on. The 4 doesn't repeat, so it's non-repeating. Letter D, we're going to get 7.745, and it continues. And letter E, we're going to get 0.316, and it does not repeat a pattern. So it does tell us these are all irrational. Okay, they're run-on decimals. We want to approximate where they're going to be located. So if I look at 3.7, 3.7 is between 3 and 4, but it's closer to 4. So I'm going to locate A there. Then I'm looking at B, 3.14. Well, that's right after 3. So there's B. C, 8.944. That's right next to 9. It's not quite 9, but it's really close. There's our C. D, 7.7. Again, close to 8, but not quite there. There's our D. And then letter E, 0.316. So that's going to be not quite halfway between 0 and 1. It'll be closer to the middle, but not quite halfway. So that's going to be letter E for us. Now, we're going to look at converting decimals to fractions in our calculators. So how do we do it in our calculators? The first thing we must do is the decimals must fill one complete row on your calculator screen, which is what they're showing in the first example. So they're showing that you're going to write 0.363636 until you fill your calculator screen. Then you're going to hit the math button and then enter. And that's going to convert it to a fraction. And it's always going to convert to a lowest reduced fraction. So let's try it with B. So in B, in my calculator screen, I would have 3.9, and now only the 5 repeats. So I would have my calculator screen repeated with 5s going all the way across. And then I would hit my math, enter. Now, if you've got one of those other calculators, come see me and I'll show you how to do the same thing. So this one's going to give us 178 over 45. So it has already reduced the fraction for us. All right, let's take a look at section D on the next page. Now we're going to be able to convert repeating decimals to fractions algebraically. So it says, let x be the original number. It says identify the digits that repeat, multiply both sides in step 1 by a power of 10 that moves the repeating part to the left of the decimal. Then you need to do the same thing, which moves the repeating pair immediately to the right, and then you subtract them. So it's going to make more sense once you see an example. So here's an example. So I want to convert this number to a fraction. So it says let x equal your original number. But you want your original number, you want the repeating digits to be right beside the decimal point on the right. So that means I actually have to move my decimal to there. So if I move my decimal to the right, that means I'm timesing it by 10. So if I've got 1x is equal to this, 10 x's would be equal to 20.51. And now I've got my, my repeating digits on the right, which is what it wanted. The next step is to take that original number, the one we started with, so this one here, 2.051, and now move the decimals so that the repeating digits are on the left. So that means I'm moving my decimal point to the right, 1, 2, 3 spaces to go right here. Yes, the 5-1 will still continue on the right, but at least the 5-1 will now be on the left-hand side. So that's what we're trying to do. So since I'm moving my decimal place 3 times, 3 spaces to the right, I would times that by 1,000. So x is times by 1,000 to give me 1,000x equals 2051.51. Now we take the large number, subtract the small number. So that's what they're doing here in step 5. They're saying, okay, let's subtract these guys. So if we're subtracting, we get 1,000 subtract 10, which is 990x equals, and now I subtract the decimals on the right. So if I subtract these guys now, I'm going to get, what's going to happen, and the whole point we're doing this, is to wipe out the repeating digits on the end. Those will cancel when we subtract. So that's what we're trying to do. So when I actually subtract them now, I'm going to get 2031. So now I get 990x equals 2031. Now I'm just solving for x. So I'm going to divide by 990 on both sides. And we get x to be equal to 2031 over 990. And then we reduce it. Your calculator will reduce for you. All you've got to do is type in your number. So you would type in 2031 divide 990, and then you would hit math, enter, enter. So reduced, it will give me 677 over 330. Okay, and our calculator would have done the same thing, but this is how we figure it out algebraically. So we're going to do 2 more examples, and then we will see how everybody else does on the practice. All right, same idea. We want the repeating digits to be right next to the decimal on the right. We have that situation here, so we can say 1x equals 0.36 repeating. However, on the right, you're going to notice I need to move my decimal to the right one. So that means it's going to start with a 10x equals 39.5 repeating. So that's a step 1 we did on both. Step 2. On the left-hand one, I need to move my decimal 2 places so that I'll have the 3/6 on the left of the decimal. So I'm going to get, so if I'm moving it twice, that would be 100x equals, however many spaces you move it is the number of zeros beside the number 1. So if you move it 1 space, it's a 1 and a 0. 2 spaces, a 1 and 2 zeros. So now this is going to become 36.36 repeating. And now we're going to subtract them. So over here, I'll reset it up. We get 100x equals 36.36, subtracting 1x, which is equal to 0.36 repeating. So now when we subtract them, the repeating digits will cancel out. 36 subtract 0 is 36. 100 subtract 1 is 99. So I get 99x's equals 36. Now I'm going to divide out my 99 just to solve for x. And we're going to get x is equal to 36 over 99, and we reduce it, which is 4 over 11. Okay, so we're confirming what we got on the previous page because we did these questions on the previous page, but we're confirming what we got. All right, let's take a look at the next one. So algebraically, we already converted the first one. Now I want the 5 to go to the left. So I go to my original number again, and if I want the 5 on the left, I need to move it 2 spots. So that would be 100x equals 395.5 repeating. And now I'm going to subtract them. So I'm going to have 100x equals 395.5 repeating, subtracting 10 x's, that equals 39.5 repeating. So again, when we're subtracting, these repeating decimals will disappear. Now I'm going to get 90x is equal to 356. Solving for x, I divide out the 90 to both sides. I'm going to get x is equal to 356 over 90, which can be reduced to 178 over 45, which is what we got on the previous page. Okay, this is just the longhand algebra way to convert decimals to fractions. You will not see a lot of this, but you do have to know how it works. This concludes lesson 3 of rational and irrational numbers.